Hi everybody, hope everybody's been having a good few days. We're well into our way for building Catbook and having a lot of fun. One thing, some announcements, I saw some feedback. People were not so excited about the pizza on Monday. Unfortunately, it is pizza today. The first 3 days had to be pre-ordered. So that is that. We'll try to keep the feedback into account for later this week and next week. So that's just out of the way. And today we're going to be talking about the backend. So not sure how many people know this term already, but in web development and for most things, programming, there's kind of two halves. There's the front end and the back end. The front end is the stuff that you've been working on the first few days. It's the stuff that users directly see and interact with. Likely it's whatever Chrome is displaying, the actual website itself. Lots of times the actual brains behind what's happening is in the back end. Most of the complex algorithms, whatever, that's stuff that goes in the back end. So today is going to be their first experience with working with it. So let's get started. Just before I actually launch into kind of how backends and servers work, I kind of just wanted to give some motivation, specifically for Catbook, why a backend is necessary. So if you can visualize and you have 3 clients, my circles are terrible, but you have 3 clients, A, B, and C. And generally, clients could be anybody, but let's say it's you guys, and whenever you're posting stories, and the current state of Catbook that we have, you can create stories, post stories, and you'll see them on your own screen. But one thing that you couldn't do is you couldn't see anybody else's story. And as well, when you refresh the page, all the things that you have posted disappear. So obviously for a social media platform, that's not too great. And so the easiest one solution to this, which is what we'll be doing, is having kind of a single source of truth for where stories go. And the way that's going to work is we're going to have to bring in some other form of communication here, where this thing is going to be the server. My handwriting is awful, but regardless, basically, say that A wants to post a story. All that he's going to have to do is he's going to have to relay to the server some information. And say then B wants to post a story. They also relay it to the server. Now the server has information for both A and B. So when C wants to get all the stories and see what has been posted by other people, now there's one source of truth that it can go to, and it just can talk to the server, and the server will respond with A's and B's stories. So that at a high level is the motivation for what we'll be doing today. Corey, who's going to be talking first, is going to be talking about what this process is like. And specifically, when a client asks data from a server, how do we render that in the front end? So that's what he's going to be working on. What Zach's going to be doing later is actually going over a technology called Node.js, which is it's basically what we're going to be running the server with in the backend. So let's get started. Brief recap. Front end is going to be your visible stuff. You worked on some event listeners yesterday. That's part of the front end. User interface design, of course, the things clients are going to interact with. HTML, CSS, JavaScript is what this is coded in. And the back end is the more hidden stuff. If you ever heard of a server, that's where the back end is going to run on. And there's databases, which is where data has to get stored. So say the server crashes, it can remember that A and B posted stories at some point. And this is written in a bunch of languages. We're going to be doing JavaScript, which is what Node.js is in. Python, many backends are done in. Java, Ruby, there's a lot of languages. So, brief idea of how this kind of works. So, nice stock image of a client, and he basically wants to communicate to a server. So the client's on the left, the server's on the right. And Catbook, of course, has the highest quality and most expensive data centers running it. And basically all a data center is just a bunch of computers that are connected to the internet and ready to serve people information. So the client is running a browser, whether it be Chrome, Firefox, Safari, Internet Explorer. Just kidding, no one uses Internet Explorer. And we're just going to, for the sake of simplicity, assume that they're using Chrome. and they're going to be communicating to the server. And for most people, they just assume like there's this vast world of the internet. Somehow you communicate a message from one point to another side of the world, and it's confusing, and you just trust in the internet. So that's good for most people, but for us as web developers, it's important to have an idea of how this works. So basically, we need some system to have clients be able to talk to servers, or basically be able to communicate over the internet. So HTTP has a long name, Hypertext Transfer Protocol. Basically is just a system in which things can, basically it's setting up a baseline for how things interact on the internet. And the reason you can imagine why this is useful is there's lots of ways of asking for a thing in English, like can you bring me this, give me this, whatever. And having some very fixed system that everything abides by, and it's very obvious what everybody wants, is very helpful, especially when there's millions of different websites, millions of clients at any given time. So we have this protocol that we have defined. There's different ways of communicating, or describing what type of communication you want to do. Those are HTTP methods. And what you send is request, and what you receive back is a response. In this class, we're only going to have to worry about two methods, get and post. The way you describe this is a get request. So a get request is basically something that you are asking for information, and you're going to be sending it to some server, asking it to send you some information. Very easy example of this. You go to catbook.com, and we describe that there's something called like web page files. So you're going to immediately navigate to catbook.com, and you're going to want to ask, well, give me the HTML. That's a GET request. You're asking for this HTML. You're not updating information. But say you navigate on catbook.com and you want to make a story. And basically you're following what A is doing and sending a story to the server, which is going to have to store some information. That's sent in a post request, which is basically what's used for updating. So very easily you can kind of distinguish what type of request you're going to be doing. Is it something that's going to be getting information, or is it something that's going to be updating information? And that's what get and post are for. There's a ton of different HTTP methods. Put is for specifically updating, but you can use post, delete. There's tons of things out there. Basically, if some of you might have the question like, oh, does it really matter? Can I use get requests for everything? And maybe at some level you cannot, but to my understanding, a lot of this stuff is basically to describe what you're doing, and it's not really, it's more so kind of to like give an idea for others what type of information you're asking for. It's going to be also important for something else that I'll describe later called APIs. So, what goes into an HTTP request? Clearly you're going to have to indicate what type of request you're sending, so get or post. Your origin, where are you coming from? Your destination, catbook.com, google.com. Relevant parameters. Sometimes say you want to get all the posts done by person A, and that's it. Well, then maybe you have to encode and add some information into your request. So those are relevant parameters. You're going to get back some things from the server. One of the most important ones, other than the content itself, is going to be something called a status code. Status codes, basically, the reason why it's 1xx is because it could be anything in the 100 range. You could get something in the 200 range, 300 range, 400 range, 500 range. Way that, just a rule of thumb, you get something in the 200 range, you're happy. You get something in the 300 range, you're probably fine. You get something in the 400 range, you're sad. Same thing for the 500 range. So 400, 500 are bad, 200 means something worked. So, just asking the audience, please, guys, raise your hands, call out. There's an HTTP status code that you guys, I guarantee, have all had familiarity with at some point in your lives. It's a 3-digit number. There we go. 404, page not found. So that is an HTTP status code. So it's something that everybody runs into at some point. People can be playful with them. Some people are just boring. This one's pretty boring. So let's try some things ourselves. So if everybody could navigate to this. I'm going to do it on my own screen, so I don't want to hide it. weblab.to/request. And this is very basic stuff. So let's click on this, and where is it going to bring us? So basically, this is just the manner in which we can send HTTP requests online. And we're going to do something super simple with this, but it's going to get the point across. So let's send a GET request to google.com. And what is nice is it tells us, well, the status code was 200, so it went through, it was all good. And it's sending back us some HTML. So, which makes sense. This is the HTML required to render google.com. Another thing that you can do, which is kind of nice, is you can kind of visualize what's happening if you go into the inspector and you look at the network. And over here, if you refresh, you see that some things went through, some things didn't go through, but these are all the requests that your front end is making right here. And this is the first thing that it asked for, is this is recbin.com, and the first thing it asked for is recbin to give it HTML, and its status code is 200, which is obvious because we can see the page. So that's just a little flavor of HTML stuff. Let's go back. So, not so scary after all. It's all you're doing is going to be sending a bunch of requests and receiving a bunch of responses and doing actions based off that. So, does anybody have any questions? Going once, going twice, onwards. So, let's go over some examples. Mentioned this before. You're on callback.com. You're going to send a GET request to some server. It's going to respond back to you with some HTML. Now you have HTML. You look at the HTML sometimes, and you'll see that it's linking to a bunch of CSS files or to some assets. You're now going to ask the server, give me those assets, and it responds back to you. And now you can load the web page. This is an example of Kappa that you've now rendered. Let's go onwards. Let's make a new story. So you make a post request because you're updating something, just like we were doing in this example over here. You make a post request. In your post request, you're going to add in information of what is the story. And it's going to send you back a response. Usually, like, what you're mainly looking for when you send a post request is the response. You want to see what the status code was. If the response was the status code 200, it means that the server accepted your response, and you're probably all good to go. If it's something like 500, that normally means something broke in the server and something went wrong. So that's something I'm sure you guys will run into. If you ever see things that are like status code 500, it means your server crashed. And Danny just made a new post, yeah. Again, any questions? All right. You can make HTTP requests from the front end as I just described, which is something that you're doing over here. Basically, you're sending things from the client to the server. You also can be sending HTTP requests from your server. Maybe your server wants to communicate with a different server. And that's also done through HTTP. So, again, some things you have to provide. One thing that I do want to mention here, which Corey is going to go into more detail later, a callback function. So many times when you're making this request, one fundamental design of the internet and basically web development is that when you're making these requests, it is not going to make any assumption about how much time that this request is going to take to come back. So maybe A lives somewhere, is in Korea, and the server is somewhere in the United States. So that's pretty far away, and let's say A is also on a really bad network connection. So this is going to take an hour from A to get to server B and get back. That's ridiculously long, but the example is good. So now A is running some code in his browser, and he wants to post the story. So somewhere in this code, it's going to be like make HTTP request. Doesn't matter. Ignore that badly written text. But regardless, you're going to send this code off, or you're going to execute this code. And most of you guys are going to be familiar or imagine that like code runs sequentially. You run this line, then this line, then this line, and every time you're going to run one line, you're going to wait for the line before it to fully complete. So that kind of idea is a little bit different in web development, because you fundamentally cannot assume how long this line is going to take, because you're going to make the communication somewhere else. So what you're going to do is you're just going to march on ahead. And this is called asynchronous programming. And Corey's going to go into this more, but basically, it's going to start executing this code without waiting for this thing to come back and finish. So that does make web programming a little bit more difficult, because say that this is going to mutate some variable, and this is going to access that variable. Well, now that you're going to have a problem, because it's going to execute just going down, and right after it sends this request, it's going to execute this line before this has gotten back to you. So what you're going to need is something called a callback function. And Rapine mentioned this earlier. The experience that you guys had with it is when you had event listeners, and you clicked the button, and you wanted some code to execute when you clicked the button. Well, same thing for this. You're going to be making a request, and when that request comes back and it's successful, you're going to want to execute some code. And that code is going to be in the callback function. So anything that's going to mutate variables that this thing is going to set usually is going to all reside in the callback function that you specify when you make this request. So this is a confusing thing for beginners. For me, it took me honestly several years to get used to doing. So don't be intimidated if you don't understand it. We're going to go through some examples today, and it's going to get hammered in by the end of IAP. Endpoints. So basically, this server, remember how we said we're going to post the story? So basically, a server has to expose several things called endpoints. Basically, what that means is that it's saying, if you want to communicate to me, you can send information to this specific address. And it's just basically making it so a client knows specifically where to talk to. So for example, for posting a story, in our case, it could be like catbook.com/story. And you might make a post request to this, it's called an endpoint, or URL. And that is how you communicate information. So these are all examples of different endpoints. If you make a GET request to catbook.com at the index endpoint, which is indicated by the slash, or you don't need that slash, it's applied, then you're going to get the HTML for the page. If you do a GET request to /use/some username, you're going to get that user's profile. Logging in is a little bit more difficult, or it's more confusing to explain whether it's like a GET or a POST request, but I'll go over that in the authentication lecture. Alright, my battery's gonna die. So, APIs. Basically, API sounds confusing, application programming interface. Don't be intimidated by it. It's something used everywhere. It's something super simple. Can somebody just grab the charger from my bag? It should just be in my bag. Just right down there. It's the one to the left. It's one to the left, Alex. Go to the right for you. Doesn't matter. So basically, what an API is the endpoints that a server can expose. So this is an endpoint, this is an endpoint, this is an endpoint, and this as a bundle can be an API. So like, what's an example? Venmo, which no longer exists now, had an API. GitHub has an API. And what that means is, say you want to get some information from, nice. Just give me 1 second. Alright, so basically, say you want to access GitHub and not just visit their webpage, but you want to send a request from your website and maybe ask GitHub for information about a specific repository. GitHub has, it's called an API, which is basically documentation online over how you can communicate to it vis-a-vis HTTP requests. And basically everything, not everything, but many popular websites out there will have APIs because people want to be able to reference things and access data from it just from their code and not through having to click on their website. If you're interested in maybe, I don't know, your website's going to use some map service provided by some website, and you want to maybe integrate it, some information that you can get from it, or maybe Grubhub, for example, and you want to get some information from it. Just Google, like, Grubhub API, and it's going to give you a whole bunch of endpoints. And we're going to go over an example together. So, I don't know, maybe it'll tell you to go to /API/u/hobbies. We'll see it together. So, make sure you still have weblab.to/request open, and open up weblab.to/API. Alright, so this is a super simple example. Basically, all that there is over here is it's saying this is what an API might look like. They'll say that, well, if you want to get information about all the employees, this is the route, so this is the endpoint, and they're giving you it right here. So let's see what this does. If I just copy this, and we go to over here, and we enter it in, and we send a request. It's thinking, but over here, it responds with some data. And that's exactly what an API is going to look like. It's very simple. It's going to provide you with an endpoint that you can access, and it will respond back to you with some data. And one thing that you might want to notice is that this data is all in JSON format. So it's very easy to parse. Though it might not be every time, it depends on how it's coded, but the standard is for it to be in JSON. If you want to get specific employees information, we can do that too. And you see, we get some data about this person. So that's, at high level, what an API is. Nothing scary, very useful. So, before we launch into lectures today, which is going to be more technical, we're going to have a bunch of workshops. Remember, backend is mostly the invisible stuff. Clients and servers are just going to be computers that are communicating with each other. The way you do this is through HTTP, and you can make these HTTP requests in your code. Any last questions before we launch into talks today, or workshops? All right, great. So Corey's going to be up first. I think one thing that I want to kind of reiterate is that this stuff fundamentally is confusing. We will try our best to explain it well to you guys, but if you are confused, like, I don't know, in lectures or whatever in class, for me it's very easy when I get confused just to like give up and like just pretend that the rest of the lecture is hopeless. Like, I would say, like, do your best, try to still follow along. The lecture later today, which is done by Zach, is not super reliant upon the stuff that Corey's teaching, so maybe you're going to find one easier than the other, but it's different for everybody, and it's hard stuff, and it's best to just chip at it slowly. Alright, are you ready, Corey?